Okay, so now let's get into actually doing a problem. Notice they're telling you to do quite a few things. First off, sketch the graph of each function. Okay, so that's the first thing we're going to do. State the number of real zeros, and that's going to be after we graph it. And then we're going to tell, that tells how many, or the number, approximate each zero to the nearest tenth, and then approximate any relative minimum or relative maximum to the nearest tenth. And sometimes they get a little bit trickier, but as long as you're reasonably close and kind of knowing the general shapes of the graph. So if we look at number one here. So if I look at number one, let's zero in on number one. I've got y equals x cubed. My highest degree term is x cubed. So now you got all these other terms on there, but if you look at the highest degree, and it's a 1 in front of it, that means an x cubed graph is going to look something like this, like we just looked at. Okay? Kind of to the lower left, it's going to be going down infinitely. To the upper right, it's going to be going up. And we might have some turns and some rises, or some falls and some rises in it. Okay, so what you need to do is you need to make a table. Excuse me. Now sometimes a graphing calculator comes in really nice because you can enter this in y equals and come up with your table. And you got to plug them in, and so it gets really complicated, and I'm not going to show all that work, but so I'm going to start at -3 here, so I would have to plug in -3 every place I see an x and go through and evaluate that. Now if you do that and you plug it all in, okay, and you can use your calculators, you get -388. So at -3, we're going to be way off the grid. So I'm not actually going to graph that point, but then at -2, we should get -248. And like I said, I'm not plugging it in, but you'd have to do -2 cubed minus 13 times -2 squared plus 56 times -2 minus 76. And I wouldn't know how to use even a scientific calculator to plug that in and enter that whole line to figure it out. At -1, we're at -146 if I plug that in. At 0, we're at -76. At 2, we're at -8. So now we're coming back down where we can actually graph this on the grid that's given. Okay, and at 3, if we plug 3 in there, we should get 2. If we plug 4 in, we should get 4. Now if I plug 5 in, I also get 4. And if I plug 6 in, I get 8. If I plug 7 in, I get 22, and I'll stop there. Now, this is kind of going to be an interesting point, what goes on right here. It's not going to be completely level there at x values of 4 and 5, even though both of them came out. That's kind of going to be where the turning point is, where it goes down, comes back up again. Okay, and we might have to look at some values in between 4 and 5. So let's graph basically starting at 2, -8. So at 2, I'm at -8. I'm right here. Now, just realize all these other values, this thing shoots down really fast as we go to the left of an x value of 2. Okay, then we're going to go at 3, we're at 2. So we're actually back up above the axis. So that means it's going to come up and be at 2 right there. Okay, and at 4, we're at 4. And at 5, we're at 4. Now, it doesn't come up here and go completely level. What that means, between 4 and 5, it's going to kind of be above 4 a little bit. And I'm going to try some values in there a little bit, But at 6, we're at 8. So this is where it shoots back up. Okay? And then, if we do some values, and I'll put them down here. If I do 4.5, I'm going to see what happens halfway between 4 and 5. Well, if I put 4.5 in, you should get about 3.9 or so. And 4.7 is also 3.9. Okay, so halfway in between. So it is a little less than that, so it comes back down. So at 4.5, we're at 3.9, just a little bit below. And at 4.7, we're at 3.9, so it comes back down just a little bit and then goes up. So it comes back down below 4 there a little bit. So I just tried a couple decimals in between. Okay, now we need to identify all of our things. So how many places does this cross the x-axis? There's only one. So there's one real zero. We need to give the number, how many real zeros. and the 0, we need to actually approximate it to the nearest tenth. And so we're going to say it's about, okay, and notice at 2 we were down at -8, and then at 3 we're at 2. So it's probably going to be a little bit closer to 3, and we're going to say it's about 2.7. And you have to be reasonably close with this, but maybe not exact. So it's about 2.7. We need to give the relative minimum and maximum. The relative min is a coordinate. Okay, now this is kind of what goes on up in this area right here. Okay, the relative min is kind of where it went back down. So it's going to kind of be at this, and this was actually like 3.875, and so this one here is about 3.85. So really it's at about 4.7 and 3.85, or we'll say 3.9. So the min is going to be at about 4.7, 3.9, approximately. Okay? And then the max, the relative max, is going to be kind of where it turned and went back down right here. Okay, and so the relative max actually at 4, 4 is where it started to go back down. Then between 4 and 5, it got down a little bit below 4. So the relative max is actually at 4, 4, because this kind of turned at 4, 4, went back down to about 3.9, and then right back up again. Okay, it's a little tough to see there, and it becomes an approximation process. So the max is at 4, 4.